Good afternoon, everyone, and thanks for joining us in the 2 days free workshop of Enhanced Oil Recovery Fundamentals, Screening, and the Role of Simulation. This workshop is instructed by Mr. Ismail K. Ibrahim, which is a senior reservoir engineer having around 39 years of wide experience in oil and gas industry. He has performed several detailed field reservoir development studies and also served with Schlumberger as a consultant reservoir engineer and business development manager in the geoscience and petroleum engineer subsegment. This session will be streamed live on YouTube also, and we will take the question answer session at the end of the presentation. So without any further delay, I would like Mr. Ismail Ibrahim to start the session. Over to you, sir.
Thank you, Shafik. Good morning, everybody, or good evening, wherever you are. And I wish that you will have a nice workshop. At least you will have some idea about the enhanced oil recovery. And I will not say all the time enhanced oil recovery. I will use EOR and the role of simulation in this industry or in EOR. First, in this workshop, we will give a short explanation of the EOR and the processes that we may follow and we may implement on the reservoir, and each process depends on several categories of the several characteristics of the reservoir and the availability of this process and can be implemented or not. But please be patient with me, because you're going to have maybe for somebody it will be the first time to know the EOR, but at least you will be prepared for the upcoming events of the reservoir life. So I will make 3 sessions, each session about 50 minutes, 45 to 50 minutes. I will give 10 minutes for just to have a refreshment or something like that, in order to refresh your mind, because any people or any person cannot concentrate on the any lecture more than 45 to 50 minutes. That's what we learned from our old colleagues. So please have your notebook with you, and just register your write down your question. I will give if I finish in the front of the time, then I will give you time for questions, and I will answer it as I can during this session. First, I would like to explain what are reserves. Most of us as petroleum engineers or geologists or petroleum geologists or petrophysicists, any person concerned with the petroleum industry knows that oil and gas trapped beneath the earth surface that can be recovered under existing economic conditions and with current technology. What means that you have hydrocarbon trapped underneath the surface in a reservoir, and either it is oil or gas, and this hydrocarbon can be recovered by the any existing technology, like it is primary primary recovery. That's by its own, by depending on the pressure and gas gas the presence of gas, or how much gas it have in solute in solution, and or the water drive, that you have a water zone and underneath the hydrocarbon that can push the oil or gas up to the surface by the producing wells. Of course, or if you have a dead, let's say a dead reservoir, then you can apply the EOR and extract this quantity of hydrocarbon. So this extraction should be with current technology and existing economic conditions, because each company have its own budget and depends on the company itself. They say to you, a petroleum engineer or reservoir engineer, you have this budget, with it, work with it, and extract this quantity of hydrocarbon for me. So economic and technical existence. What do you have? It depends on your situation. Let's go further and see what will come up. First, we have role for each person in the concerned with the oil or gas industry, let's say petroleum industry. The first person, or the most concerned person, is the reservoir engineer. What is the role of reservoir engineer? Optimize depletion plan and economics. You have to look after your plan and how to optimize it. Develops reservoir models to forecast well and reservoir performance. This is done by simulation, and we will come later on what the simulation will do for you and what will give you, and how to forecast the quantity and the performance of quantity of hydrocarbons and the performance of the well or the reservoir. And also, reservoir engineers should performs reserve estimate and audit for financial accounting. You have to, by simulation or by technically, this is the normal calculation methods. You estimate the hydrocarbon you have and be sure of it and sure of the quantity you have. Then give it to the financial people to make the financial accounting and decide what they will get from and how much they will get from this result. This is your role, reservoir engineers. So be careful and be concise in the and be strict to estimate, because later on you will be asked, oh, you gave us a wrong number, you gave us something that don't fit to the what we are seeing down there and what we can extract. So be careful, please. Then if you have a let's say for the discovery of any hydrocarbon, you have many artificial of many methods, several methods. You have natural flow, you have artificial flow, and you have methods to improve recovery efficiency. If you cannot go with the natural, you cannot go with the artificial lift, which are the conventional recovery methods, then you have to go by improve recovery efficiency. How to improve it? You can improve it by actually 3 ways. This is the enhanced oil recovery, REOR, and you can improve production or injection control. You will have you have to have control over these uh, over the production or the injection of any fluid you are injecting, either water or gas, or even sometimes we use fuel, some kind of fuel, and some gases that's natural neutral gases like CO2 or nitrogen. But in the normal conditions, you usually use water to inject into the water zone in order to raise the pressure and the flow of, we give way and we push the oil. For example, we push the oil up to the uh, required levels and push it to go through the producing wells. Then the third one is the strategic wellbore placement. This is a very important method of improving recovery, which is well placement. Well placement is very important. You have to have the full strategy of production. You have to have the wells that you have, and what kind of wells, either they are single, dual, or something like that. This is doesn't matter, but the spacing of the allowable spacing between the wells is very important. So you have to be careful in placing any well, and this we can come through that one, or you can go through this one in other training courses that called simulation with well placement, well bore placement. So we will leave some actually we will leave some details to later on courses. Then what are the enhanced oil recovery or EOR processes? EOR processes include all methods that use external sources of energy and or materials to recover oil that cannot be produced economically by conventional means. This is an explanation of the EOR, which tells you that this is the method or the process that you use external sources, not the energy or that you have, or the conventional means of producing this quantity of hydrocarbon. So you have to look for other energy to recover that quantity of hydrocarbon. So this is called the EOR, in which you cannot, in which means that if you cannot extract or produce that quantity of hydrocarbon, then you have to use some external sources of energy. Then, if we go water flooding and enhanced recovery. Most of the companies nowadays use the, and I think you have seen so many examples of that. They use water, they say that we inject water in order to recover the hydrocarbon. This is normally done this is the traditional method actually. The traditional one, is the easiest one, and it is the most available is water, so they can use it to recover what's left. Then most of the companies look after the economic side of the operations. So they then later on, if they find that this traditional method cannot be used to recover, or the recovery is very low, and the water oil ratio is rising, so they go to the other EOR methods. And then we have the traditional methods are often called secondary recovery. We usually call it secondary recovery. Of course, as you know, we have primary recovery, secondary recovery, and tertiary recovery. Traditional method, the primary recovery is one that uses the energy that's present in the reservoir, either by solution gas or by water injection or a combination of gas cap drive and the water drive, when the combination of these drives, or even sometimes gravity drive. So, and then we have secondary recovery. We have to use we go to the EOR. And tertiary recovery, this is something beyond our learning for the time being, because it is more advanced methods to produce the hydrocarbon from the reservoir. So let's leave it now. Enhanced recovery is a US government term that refers to, look here, you will always see or hear that's US government term. Why we use this one? Because the API, American Petroleum Institute, and the most industry centers and the research centers about the hydrocarbons, or mainly hydrocarbons, are present in the US, and the US have very strict laws or very strict regulations how to recover any hydrocarbon present, and be careful for the water, underground water, because underground water for the government is very important. So they have to put strict regulations on how to deal with it when you drill a well and face water resource. This term refers to four categories. First one is steam injection and in situ combustion. We will come, of course, through these categories one by one later on the sessions. And then they have, it means the polymers that's used, and hydrocarbon miscible polymers or hydrocarbon miscible fluids that can be used in the EOR. And then they can use carbon dioxide, also categorized within these four categories, and the enhanced recovery EOR. And then there are surfactants and bacteriological material. All these four categories are considered enhanced recovery. So please write down what you want to ask for. So later on, I will give you, as I said, give you some time for asking. And for any explanation, please also keep it later on. Water flooding. Water flooding. The current recovery or improved oil recovery processes are water flooding, as we said. We explained what's the water flooding, as in all of you may know that it is a normal method used by the excuse me. So water flooding, as we said, we have talked about it. Then we have thermal methods. Thermal methods include steam stimulation, steam flooding, hot water drive, and in situ combustion. Of course, we will talk about these methods one by one and see what is the difference between each one of them. And we have the chemical methods. Chemical methods, here we use polymer, we use surfactant, we use caustic material, and micellar polymer flooding. This is a combination of the polymers that makes the driving material, driving fluid that pushes the oil through the the producing wells, and we will go on one by one later on, please. Miscible methods including hydrocarbon gas. We inject hydrocarbon gases. We inject CO2, nitrogen, and flue gas. We produce during the production the gas that's available, or the solution gas when it is revealed to the surface and released and the surface can be injected again in order to have the driving mechanism, or to change the characteristics of the hydrocarbon down there in the reservoir, and we can produce the available hydrocarbon. Also CO2 does have the same effect, nitrogen also, and flue gas. All these methods, water flooding, thermal methods, chemical methods, and miscible methods. All this will come later on and one by one, but just to give you an idea about what's the meaning of improved oil recovery. These are the currently used ones. And as you see from the currently used improved oil recovery processes. But with the detailed course, of course, we will have some time, more details and more talk about it. Water flooding highlights. Water flooding highlights started by accident in Pennsylvania in the late 1800s. Produced more oil than any other improved recovery method. Involves immiscible displacement of one fluid, which is oil, displaced by another, which is water, and the reservoir. Water is usually plentiful and cheap, so that's why the widely used one. Description. Water flooding consists of injecting water into the reservoir. Most widely used post-primary recovery methods. After the primary recovery method, we may use the water flooding. Water is injected in patterns or along the periphery of the reservoir. We have some kind of patterns that's used for injection. Either we use, as we have, maybe you have here before that, so you know, that's we have several patterns. That's 5 spots, 7 spots, 9 spots. 5 spot is one injection, one producer, and 4 injection wells, water injection wells, or 7, which means that we have 6 injection wells and 1 producing well. Why we use this kind? This can be explained later on. Also, we will explain. The mechanism that improve recovery efficiency in this in the water flooding is water drive and increase pressure. When you inject water on the bottom or on the sides of the peripheral of the reservoir, when you inject water, you increase the water drive energy, raise it, or you increase the pressure in the reservoir in order to push the hydrocarbon through the producing well. This is the diagram showing the simple diagram actually, showing the water flooding facilities. You have an injection well, which is what you see on the left side of the screen, and you have a water injection pump that receives the water from a source and injected it through the injection well. Then this water, when it comes to the oil zone, it pushed the water, as you see from number 2, which is the injection water, and then pushed the oil, which is here and noted by number 1. It will push the water to the producing well. Then production done either by mechanical, like you see here is a second rod pump, or naturally will come out. And then you have a separation and the storage facilities. This is in general, but of course the some other units are present for the purification of the water used in the injection. We have water flooding have limitations also. Uh, the high oil, if you have high oil viscosity in the reservoir, then injecting water, that's if the viscosity of the oil is higher than the water, then you will have higher mobility ratio. That's you will face the fingering of the water, and the water will produce from the producing well earlier than the oil. Uh, some heterogeneity is acceptable, but avoid extensive fractures. When you have extensive fractures, then also water will come out before coming earlier than what is expected and was supposed to be. The challenges, the challenges that we have poor compatibility between the injected water and the reservoir may cause formation damage. And then, for what is the formation damage? When water comes pushes oil, it will, if the viscosity is higher than the of the oil, higher than the water, then you will leave too much oil in the reservoir. Subsurface fluid control to divert injected water and to shut off undesirable produced fluids. Here we have on the surface, there will be separation between oil and water. Then you go back and inject the water again into the injection well in order to use it also in the water flooding. Then we have immiscible displacement. Immiscible means that the interfacial tension between two phases in the reservoir, water and oil, is greater than zero, which means that you have that you, in order to avoid producing water before the producing oil, then you have to have a higher interfacial tension between the two fluids in order that you produce water before producing the oil. Thus, the two phases cannot mix molecularly. So also in order that they don't mix, understanding immiscible displacement requires a knowledge of a frontal advanced theory. Of course, here, so we don't have time to explain what is the frontal advanced theory. You may go back to the references, that's by Dake, it is Reservoir Engineering by Dake and Craig. Dake explained it in chapter 10 and Craig explained it in chapter 3. So take note of that reference if you want to go and see what is the meaning of the frontal advanced theory. And maybe some of you have studied this one in the college. Okay. Polymer flooding highlights the description. Yes, it is a polymer. Augmented water flooding consists of adding water soluble polymers, adding water soluble polymers to the water before it is injected into the reservoir. I think it is quite clear that's what we mean, that we have a polymer, we add it to the water, the injection water, and then this injection water will mix together with the polymer and can be injected into the reservoir. What is the mechanisms that improve recovery efficiency? Here we have the mobility control by using a certain polymers. After, of course, you do the polymer flooding and any other chemical flooding by making or any ER, you have to have a pilot plan or a pilot wells that you inject. We use it as a trial just to try whether this is working or not, and most of the cases use it is with the polymers, because polymers are very sensitive material, and we have to have the right polymer for the reservoir, depending on the characteristics of the oil in the reservoir. So here we improve mobility control. So in order that the polymer will not be produced in the front of the oil. So it always stays behind and push the oil to the producing well. This is also a simple diagram that's show you the zones of the oil, water, and polymer. We have the producing well, separation and storage, water injection pump, injection well, and the polymer solution from mixing plant comes to the injection well and mixed with the injected water pumped down. So you see here, number one is the oil zone. Number two is the free zone, which means that's the oil followed by polymer solution. Polymer solution, and the polymer solution should be followed by driving water in order that they mix then down there in the reservoir, and some of it, of course, mixed in the when pumped through the well and this on the surface. So you can push the oil to the producing well, and then when it goes up to the surface, you use the separation and the storage facilities in order to separate the oil from polymers, and then the pump it to the mix storage facilities. Polymer flooding limitations. High oil viscosities require a higher polymer concentration. If you have a high viscosity oil, then you have to have higher concentration. Results are normally better if the polymer flood is started before the water-oil ratio becomes excessively high. In this case, you have to have start the polymer flooding before the water-oil ratio becomes higher than the acceptable. So several tests have to be run before deciding what polymer and when to use the polymer for flooding. Clay increase polymer absorption. If you have a clay within the producing formation, then you will have a problem that will be absorbed. The polymer will be absorbed by the clay. Some heterogeneity is acceptable, but avoid extensive fractures. Also, as we said, extensive fractures will lead to produce the polymer before producing the oil, or increase the water, increase the polymer oil ratio. Also, the cross-linked or gel polymer techniques may be applicable. So be careful when you use polymer. If you decide to use the polymer, actually this is the least used one. The polymer flooding is the least used one in the around the world in the sorry. Challenges of the polymer flooding are lower injectivity than with water can adversely affect oil production rates in the early stages of the polymer flood. So lower injectivity, of course, some formation, you have to test the formation and the injectivity, water injectivity of the formation, and when mixed with polymer, what is the what is the injectivity of the formation. You have to also take care into, you have to consider before using the polymer. Type of polymers. For example, acrylamides type polymers lose viscosity due to shear degradation, salinity, and divalent. Sorry. Sorry. The type of acrylamide type polymers, they use viscosity due to degradation and the shear degradation, the presence of salinity and divalent ions. Xanthan gum polymers cost more, are subject to microbial degradation, and have a greater potential for well-bore plugging. So you have to take, actually the xanthan gum polymers and the acrylamide type polymers are less used than supposed to be around the world. So be careful when you choose the type of polymer that you are using. Surfactant flooding. Surfactant flooding consists of injecting a slug. Listen here. A slug that contains water, surfactant, electrolyte, which is salt, usually a co-solvent, alcohol, followed by polymer thickened water. You have to be careful in choosing such a kind of surfactant, which contains a lot of material here, contains water, surfactant, electrolyte, salt, usually a co-solvent, alcohol, which is this is a very expensive part of the, besides the polymer, extensive part of the flooding, this type of flooding, and polymer thickened water. As polymer, when mixed with water, it will thicken by time. What are the mechanisms that improve recovery efficiency? Here we apply this method and it will affect the interfacial tension reduction, improve displacement of sweep efficiency. Of course, during the pumping of any surfactant or any material, that's the surface tension by time will degrade and will be reduced. So we use here the surfactant and polymer flooding. This material usually used that's improve displacement sweep efficiency, that controls the interfacial tension and keep it in certain on certain levels in order that we can they don't mix together with the oil. And then here also we control, you see here, mobility control improves volumetric sweep efficiency. The interfacial tension, if reduced, it will mix with the water and may produce before producing the oil. So in this case, in this method, we keep on the interfacial tension as high as possible, so that the two fluids, these fluids or the surfactant or the flooding fluid, do not mix with the oil. So in this case, we improve the volumetric sweep efficiency of the method. Also, this is a diagram of the kind of facilities that we have up on the surface, and the kind of method that's used. First, we here, as you see, we use after the oil comes the surfactant, and then polymer solution, and then driving water. So it contains a lot of stages, actually, three stages. Besides the oil, we have four. We have the oil, we have the surfactant, then comes the polymer, then comes the driving water. So in this case, the surfactant will act on the polymer solution, that's to increase the surface tension in order that it don't mix with the water and improve the mobility. What are the limitations? Limitations of this method, surfactant polymer, are an aerial sweep of more than 50% of water flood is desired. Relatively homogeneous formation. High amounts of anhydrite, gypsum, or clay are undesirable. So you see here the limitations are very strict, and you have too many bumbles you have to come over in order to use this method. Available systems provide optimum behavior within a narrow set of conditions. With commercially available surfactants, formation water chlorides should be less than 20,000 ppm, and divalent ions, carbon, calcium, and magnesium should be less than 500 ppm, part per million. Challenges: complex and expensive system, possibly of a chromatographic separation of chemicals, and high absorption of surfactant. Interactions between surfactant and polymer may happen. Degradation of chemicals at high temperatures. You have here a lot of obstacles you have in your way to use this method of flooding, surfactant flooding. We have here miscible gas injection of flooding. Here we use CO2 injection because CO2 is miscible, can be miscible with the oil, so it will act on the oil viscosity and the oil and the mobility ratio. It is CO2 flooding consists of injecting large quantities of CO2, 15% or more hydrocarbon per volume. We have to use 15% or more than 15% of the hydrocarbon volume in the reservoir to form a miscible flood. The mechanism that improves recovery efficiency: CO2 extracts the light to intermediate components from the oil, and if the pressure high enough, develops miscibility to displace oil from the reservoir. I think it's quite clear here. It's what happens down there is that the CO2 will grab the light to intermediate components of oil, and if you have higher pressure, it will mix with the oil and develops miscibility to displace it from the reservoir. And then viscosity reduction and oil swelling. This method, CO2 injection, is now widely used because it is more effective and economical, less and CO2 these days are available with the certain plants that produce CO2 for injection, but it needs a high quantities of CO2. This is a diagram of the miscible gas flooding, CO2 injection. We have here CO2 is pumped at the same time with pumping the water. Also, we have 4 stages, or actually 4 four fronts, let's say. First, we have the oil. This is number one, oil zone. Then we have oil bank miscible fronts. That's materials. When we inject CO2, it does not melt or does not go miscible mix with the oil. It will mix this by stages. Then we will have CO2 and water zone. And then we will have the water drive that will push all these fluids to be in contact with the oil in order to be pushed through the production well. Miscible gas flooding, CO2 injection, limitations, very low viscosity of CO2 results in poor mobility control. I think it's quite clear. The availability of CO2, sometimes it is not available as required. So you have to have some time and you have to wait. You have to have a storage facilities for the CO2 in order that you can come up with the required quantities to be injected. And the surface facilities here, as I said, we need very complicated, actually, very complicated surface facilities in order to that you can keep, you can separate the gas, the CO2 from the oil and reuse it again. And this is very difficult actually in the field. But these days there are several companies that can offer you these facilities within a certain cost, and this is an extra cost should be added to the cost of the whole operation. Also, the challenges. This is actually the last slide for this session, and I will give you some few minutes in order that you can prepare your questions. Challenges, we have early breakthrough of CO2 because of the viscosity difference between oil and CO2. Corrosion is producing wells. That's the mixture of CO2 with water will make corrosion material that will corrode the downhole facilities. The necessity of separating CO2 from hydrocarbons, repressuring of CO2 for recycling, and a large requirement of CO2 per incremental barrier produced. I think this is, we should stop for a 10 minutes rest so we can come back